One of the most common ways to build resilience into our systems is through redundancy. Common design elements for redundancy include the following: geographic dispersion. Oftentimes, things that may disrupt your workflow or your systems or provide some major disruption to your organization are geographically related. So it may be something like a hurricane, a tornado, some kind of natural disaster, or power outage, whatever that may be, often is kind of hits a specific geographical location. So one way we can build in redundancy is to have systems or infrastructure in place in multiple locations. A general rule of thumb is something like 90 miles apart to avoid common natural disasters. So again, general rule of thumb, not a hard rule, but generally upwards of 90 miles apart to maintain the security of our infrastructure. Separation of servers and other devices. In our data centers, we may want to separate out our servers and other devices or disperse them throughout our data center so that if a single rack fails, it will not take out all of our infrastructure or all of our servers. Multipath networks. Here we want to make sure that if a single device fails or a single cable or something like that has some type of issue, we have another option to fail over to. Redundant network devices and systems. This is a fundamental aspect of high availability design. Essentially, we're ensuring that we have redundant hardware, firewalls, switches, routers, so on and so forth. We have a couple of examples of how we implement this type of thing: load balancing and clustering, power protection, and backup power. Power outages are a frequent problem that can happen just about anywhere. So we need some way to deal with that in the event of a power outage. Two common ways: a UPS and a generator. Generally, if you're expecting to deal with a longer, more sustained outage, a generator would be the solution for that. Platform diversity. There are some pros and cons to platform diversity. We're mostly going to focus on some of the positives right now. The benefit is that if there is some sort of hack or one organization is compromised, you're not entirely dependent on that one organization. If one organization services go down and it takes down your entire network or your entire system or all your services, that can be a bit of a problem. So one of the benefits is that if we diversify our products or we diversify our services or who we shop with, who our vendors are, we can generally maintain support in the event that one organization goes down or has some other stuff. At least it doesn't take down our entire operation. Again, there are also a lot of cons and drawbacks to diversifying the platforms that you work with as well, but for the sake of resiliency and redundancy, generally platform diversity is going to offer you more benefit. When architecting our design, these are some key considerations: availability, resilience, responsiveness, scalability, ease of deployment, risk transference, ease of recovery, patch availability, vendor support, inability to patch, power consumption, and compute requirements. One other thing that's not on this list would be cost. Okay, we're primarily going to focus on resiliency in the context of storage, so backups, replication, that sort of thing. We're going to do a quick run through of everything on this list, and then we'll go through them one by one in a little bit more detail. We're going to cover RAID, copy of the live storage system, snapshots, images, VDI, copies of individual files, and backup media. First on the agenda is going to be RAID, redundant arrays of inexpensive disks. These are some different types of RAID. The most common ones would be that, or at least the most common that you're likely to encounter would be RAID 0, RAID 1, and then RAID 10, or sometimes referred to as RAID 1 plus 0. For RAID 0, data is striped across all drives. For RAID 1, data is mirrored, and RAID 10 or RAID 1 plus 0 is a combination of 0 and 1. So you stripe and mirror the data. Let's talk about copies of the live storage system. First on our list is just the good old-fashioned backup, which is essential for data loss prevention. We have three types that we're going to look at: full backup, incremental backup, and differential backup. A full backup will copy the entire device or storage system. A full backup will generally require more resources and more storage. An incremental backup captures changes since the last backup. It'll save space, but will require more time to restore, as each set of changes must be applied sequentially. A differential backup is going to sound very similar to an incremental backup. A differential backup captures changes since the last full backup. Incremental backups and differential backups can sound very similar. I think if you're encountering test questions on this, the key verbiage that you might use to differentiate between the two would be that if you see the words changes since the last full backup. So since the last full backup, you're dealing with a differential backup. Replication. The idea here is we're doing continuous copies of the live data to another location or device. So it's a continuous copy. There's two categories, synchronous replication and asynchronous replication. Synchronous replication is a real-time copy. Asynchronous replication occurs after changes are made. Next, we have journaling. This is something that logs changes to data that can be reapplied for restoration. You often see it used with databases. It's ideal for environments with frequent changes or updates. A big advantage is that it allows point-in-time recovery. Okay, we're on to snapshots. I apologize in advance. This is a massive wall of text here. We're actually going to do snapshots, images, and then some distinctions between the two cases. Let's cover snapshots first. This captures the full state of the system or device. This is usually useful for virtual machines or virtual desktop environments. The idea here is we are restoring the machine to the exact moment the snapshot was taken. Can be useful to clone a system or revert to a state before a patch, a bug, or some other kind of event. You can perform live backups with minimal performance impact. Images, these represent a complex bit-level copy of a system. So the idea here is that with an image, we have a very exact, very precise replica of our system, usually used for servers or complex system environments. So if I was to try to put a fine point on the difference between the two, because they sound very similar, snapshots offer quick point-in-time recoveries. Again, especially useful for VMs. So if you're talking about snapshots, you're probably talking about virtual machines. Images provide comprehensive system backups. So again, a more in-depth, more comprehensive, more detailed system backup. This is ideal for complex server configurations. So if you see server configurations in the question, you're probably dealing with images. If you see VM in the question, you're probably dealing with snapshots. Virtualization and VDI. The idea here is usually in this type of environment, we are creating non-persistent systems. So we utilize something called a gold master image to create temporary non-modifiable instances. Each time one of these systems is restarted, it will revert back to its original state. This is often good in educational environments or in shared desktop or shared workspace environments where you want each user to have an exact sort of steady state that they start with each day. Another type of backup, individual files or file level backups. This is pretty much exactly what it sounds like. Instead of backing up an entire system or device, we're just backing up individual files. Up next, we need to talk about common backup media. Where is this stuff being stored at? Tape has historically been a low-cost per capacity solution. It would be used in a large enterprise environment. Disks tend to be a little more expensive than tape, but they're also faster. These can also be used in an enterprise environment or for network attached storage or SAN arrays. Let's talk about optical media. So we're usually thinking of things like Blu-ray or DVDs. These tend to be less common for large-scale backups due to capacity limits. Another type of storage media that the average user may use is something like flash media, micro SD cards, USB drives, that sort of thing. Typically, that's not suitable for enterprise level operations. A little more on backups here. We're not going to go in depth on this slide, but I just wanted to throw up this key terminology in case you encounter it and you are familiar with what any of this verbiage means. One important note, this is not different options. These are not necessarily mutually exclusive. Some of them might be. For example, you probably don't have the same backup as an online and offline backup at the same time. You could have a separate online backup and a separate offline backup. Generally, you wouldn't refer to the same backup as being both. But that doesn't necessarily mean everything on the list is mutually exclusive. These are some key considerations for third-party backups options. So if you're using some kind of SaaS type solution or some sort of third-party vendor for your backups, these are some things that you need to think of. Bandwidth requirements, time to retrieve files and cost to retrieve files, reliability, and security models. As a general IT engineer, you're probably not going to have to make these decisions, but you will probably have to make recommendations based on this type of information. And generally, some higher level management will have to assess their risk tolerance for downtime. How long are they willing to be down? What are the costs associated with this? These may be some key factors that you need to consider in your evaluation when you're presenting your recommendations. Scalability is pretty essential to modern environments. We need to allow services to expand across multiple servers rather than relying on a single larger server. Scalability generally falls into two categories: vertical scalability and horizontal scalability. Vertical scalability, we're looking at sort of a single, larger, more powerful device. Horizontal scalability, we're using lots of smaller devices or systems, but we're adding more of them. So horizontal, quantity; vertical would be singular, more powerful. We have three types of disaster recovery sites: hot sites, warm sites, and cold sites. Hot sites are generally fully operational data centers with all necessary infrastructure. These tend to be far more costly, but your time to recovery is much quicker. Cold sites will generally provide something like space, power, network connectivity, but everything isn't already configured and ready to go. There's going to be some significant downtime associated with getting everything up and running. This is generally a much more cost-effective solution if you have a higher tolerance for downtime, whereas if your organization has very low tolerance for downtime, you may want to consider a hot site. There is a nice balance in the middle called a warm site. It's partially equipped with necessary systems, but lacks live data. Again, this would generally be a balance between the two costs. So in summary, hot sites, more expensive, faster recovery; cold sites, less expensive, longer time to recover; warm site, kind of a happy medium between the two. And while I say happy medium, that doesn't necessarily mean it's always the most optimal solution. Some organizations have very low tolerance for downtime. Some have a higher tolerance for downtime. You need to evaluate your needs for your organization and make the best decision you can based on that information. If we have some type of total outage, we need to prioritize what comes back first. This is not an absolute law of the land, but it's generally a pretty good guideline to consider. Restore network connectivity, restore network security devices, restore storage and database services, restore critical operation servers, restore logging and monitoring services, restore other services as possible. In this slide, we're going to look at three areas for capacity planning. So our main focus here is capacity planning. The three key areas are people, technology, and infrastructure. People can often be an overlooked element. As an organization grows, it's important that we have enough staff, qualified and capable staff, to meet our needs. Also, in the event of a disaster or for disaster recovery, we want to make sure that we have some plan for people to come in and do the job they need to do. If we have some kind of disaster that wipes out our data center and we have a remote location already ready to go, some sort of hot site that spins up immediately, but all of our staff, all of our qualified personnel are unable to work, then it doesn't do us a lot of good. So we need to have some consideration for that. Testing resiliency and recovery controls and design. We need some way to test or evaluate our systems. Will this really work? Will this really meet our needs? There's a handful of ways we can go about testing our systems and services. Tabletop exercises. This involves discussions among personnel to validate recovery plans, identifying potential missing components. It's the least disruptive, but also the least reflective of the real-world scenarios that we might encounter. Simulation exercises. These are drills where staff simulate their actions. This offers a balance between testing effectiveness and operational disruptions. Parallel processing exercises. This entails moving processing to a hot site or backup system to validate backup performance. This can have larger risks of disruption. Failover exercises. This involves testing complete failover to alternate sites or systems. This represents a very high or possibly the highest disruption risk. However, it would also provide the most accurate real-world scenario testing. Let's talk about site security. So we're primarily focusing on physical, real-world security at this point. Some common things that we can use for physical security would be things like industrial camouflage, fences, bollards, lighting, badges, signage, alarms, man traps, fire suppression systems, locks. This is just a quick image of a bollard. Usually these are designed to prevent vehicles from passing through a specific area. We also have just a quick graphic for an access control vestibule, also usually called a man trap. You have some kind of low secure area. Before someone can go to the higher security facility, they have to enter some sort of man trap or access control vestibule where their access is authenticated. or where they are authenticated and either granted or denied access, and they are stuck in this area if their access is denied. Guards are also an important option for physical security. Guards can provide both detection and response capabilities. They can validate individual identities, and one of the biggest drawbacks is guards tend to be fairly expensive. There are a whole variety of different cameras with different functionalities. The functionality of camera systems has definitely gone up dramatically in recent years, or at least the sort of availability of these functions at lower cost price points. Oftentimes these cameras have pan, zoom, tilt capabilities. Some cameras also have more advanced functionality like facial recognition, gait recognition, or other more advanced detection features. Here's some key types of sensors that you may encounter: infrared sensors, pressure sensors, microwave sensors, and ultrasonic sensors. Infrared sensors detect changes in infrared radiation. Pressure sensors sense change in pressure. Microwave sensors detect emitted microwave changes. Ultrasonic sensors are pretty good for proximity detection. Okay, that's all we have for this week. I think a lot of the subject material here, while it's very important, is a little more intuitive and a little more straightforward than some of the other stuff we've talked about. So I hope you enjoyed the class. I hope you enjoyed the information, and I hope you have a wonderful week.